Hello class, this is Mr. McAllen, and I promised you that I would give you a video lesson for over the weekend for how to handle those trig ratios that we were talking about the other day. Now these trig ratios are supposed to be such that you don't have to use a calculator. So I don't want you to use a calculator at all. We're going to go through all the objectives, and in terms of what we see here, we're going to review the reference triangles, we're going to review the reference angle, just to make sure we're all on the same page. We're going to talk about trig ratios using x and y coordinates around the unit circle, and we're going to find the trig ratios for where we have reference angles of 30, 45, and 60. And then we're going to talk about special quadrantal angles where their reference angle will be 0 or 90. And then lastly, we want to make sure that we always check the sign of our trig ratio to make sure it's correctly displayed as far as whether it's positive or negative. So there's a neat acronym that we have for that, so we can make sure that we get the sign of the trig ratio correct. So what we're going to first start with is we have the reference triangle, and notice I don't have reference triangles drawn, but I have a square, which I'm going to just label the sides to be all S. And this is a square. It has the reason why we use a square is because that's where we get our 45, 45, 90 from. So if I label these sides as 45, 45, and 90, the hypotenuse side, if you did Pythagorean theorem, would end up being S root 2. So that's where we get our 45, 45, 90 sides when we write them in on our test, or when we see the SAT and they give us that information. They give us S, S, and S root 2. Now we have over here an equilateral triangle, which means that everything is equal. Angles are equal and sides are equal. But I'm going to call the sides length of 2x. This will just make my calculations easier. And when I drop the height into the middle of the triangle, you'll see that this side becomes x. This angle is 60. This angle up here has got to be 30, because all the angles have got to add up to 180. And this side here is just going to be x root 3. So this is where we get our 30, 60, 90 from. If you're ever kind of forgetting which side should be what, we have 2x, this is x, and this is x root 3. And you have to remember that opposite the 60-degree angle is the x root 3. Opposite the 30-degree angle is our smallest side, the x side, and opposite the 90 is our largest side, the 2x. So now we're going to use that information to help us find trig ratios. So when we do this, we're going to, well, first we have to consider, when we give you an angle other than 45, 60, and 30, when we give you such as a sine of 120, we have to figure out what the reference angle is. Now this reference angle is going to tie into one of these two pictures. So what we first do to find the reference angle is we just draw our coordinate plane, and we put our angle in standard position. So for the sine of 120, I'm going to draw an angle in standard position. I'm going to open up the angle to 120 degrees, and this is, remember, this is 90 and this is 180. These are like our kind of mile markers that tell us where we are exactly. This is 270 and 360. So 120 degrees has a reference angle of 60 degrees, because 120 plus 60 will give us 180. So for this angle right here, I would write the reference angle is equal to 60 degrees. If we look at the cosine of 60, when I draw a 60-degree reference angle, what you'll notice is if you have an angle that is under 90 degrees, then the reference angle is just 60 degrees. Now, the definition of a reference angle, the way I explain it in class, is if you take the terminal side and you find the amount that you have to wind that terminal side back to the horizontal, that's your reference angle amount. The reference angle will always be between the smallest angle between the terminal side and the x-axis. So if you notice over here, if the angle is 60 degrees as a normal angle, the amount that I would rotate it back to the horizontal would be 60 degrees. So that's pretty easy. If you're in quadrant 1, the reference angle is the angle. Now if you have 225 degrees, I'll draw another picture. So here we have our coordinate system, 0, 180, not 180, 90, 180, and 270. And I pace out what 225 degrees would be. So I'll draw my angle in standard position. Here's my initial side. Terminal side comes around. So this is 225 degrees. The reference angle is how much I have to go back to the nearest horizontal. So that would be a 45 degree reference angle. And then the last one, let's look at for finding the cosecant of 300, we need to figure out the reference angle for 300. So I'll draw my coordinate axes again. Remember that's 0, 90, 180, 270, and this would be 360 again. So I'll draw my angle of a 300 degree rotation. So this is 300 degrees. So how much does it take to get back to the horizontal? Well, if this is at 300, then I would need 60 degrees more, and that would be my reference angle. Okay, so hopefully that helps you. Now here's the big mistake people will make. So this is incorrect. On that last angle, people will rotate all the way to 300, and they'll think that this is going to be the reference angle, and that's not correct. It's not 30 degrees. The reason why? The angle has got to be how much more you need to take it to bring it back to the horizontal. So in this case, since we're at 300 degrees, we have to go 60 degrees more to get to horizontal. Okay, so that is our short lesson or portion of how to find the reference angle. Now, how do we use this to well, in a minute we're gonna learn how to use this to find our trig ratios, but we're gonna first talk about considering trig ratios using x and y coordinates. So in this case, it says here, think about trig ratios using x and y coordinates. We're going to consider an angle of 135 degrees. So I'm going to draw my initial side. I'm going to rotate my terminal side to 135 degrees. And now I'm going to draw my reference angle. So my reference angle is right here, and that's going to be 45. I'm going to drop the vertical side, I'm going to draw the horizontal side, and hopefully you recognize from class that you know, we see that the way I drew the arrows here is you know, we're constructing our reference triangle, and hopefully you could see that the one side here is going to be S, the other side, or you can label it whatever you want, but this would be equal to S, this would be equal to S, and this would be equal to S root 2. Well, as long as you keep the sides the same length, you can label this to be a coordinate. So what I choose to do is I choose for this triangle to choose my sides to be 1, actually negative 1, positive 1, and then this side just has to be equal to root 2. So my x and y coordinate here would be negative 1, comma 1. Now when it comes time to do your trig ratio, let's say that I asked you to find the sine of 135 degrees. Once you draw your triangle that way, then you can think of it as being opposite over hypotenuse, which is 1 over root 2. But in other places in our textbook, it will say you can think of the sine ratio to be equal to the y coordinate divided by the radius. And I hope you notice that this is the y-coordinate and this is the radius of the circle that this this terminal side would make as it goes around the circle 360 degrees. So make sure when you're doing this problem, if you wanted to, you could consider this side to be s, and this side to be s, and this side to be s root 2. If you want, you could consider the coordinates to be s, negative s, comma s, if you didn't want to put a value in there, if you want to keep it variable. But what a lot of people do, and what you'll see our textbook do, is they insert a value for s. They could make it equal to 2, negative 2 and 2, and then that would make this side 2 root 2. I use the value 1 because it makes it easier to simplify. So I can make this value 1. This side would be negative 1, and this side would just be 1 root 2. And then I construct my trig ratio using either opposite over hypotenuse, or as the book will have it, the sine ratio can be thought of as being the y side over the radius side. So what I want to do, because this is kind of a new thing for us, is let's look at the next step in the progression of sine, cosine, and tangent. The old way was to think of SOHCAHTOA. And that was where you took the, when you identified your angle, you said opposite over hypotenuse, or you said adjacent over hypotenuse, or you said opposite over adjacent, and then these sides were just the reciprocals. So that's kind of the old way we used to do things. But now if you consider it using coordinates, and we consider an angle in standard position, and I'll just go back to the triangle we had before. Here's theta. This was a y side, this was an x side, and this was the radius. You can consider the sine of the angle to be y divided by the radius. The cosine was x divided by the radius, and the tangent was y divided by the x-coordinate. And the same thing applies in terms of the reciprocal relationships. You have the radius over the y side, you have the radius over the x side, and for cotangent you have it ends up being x divided by y. So that's just, if we're going to be putting our angle on the coordinate plane, these are alternative ways that you can think about the sine, cosine, and tangent ratios. So now we're going to use that information to help us figure out the sine of 120 degrees. So again, we'll go through the steps. I'm just going to use red so it highlights the angle. We have 120 degrees. I'm going to draw my angle to 120 degrees. There's 120. And now I remember that I'll draw in my reference triangle. And my reference triangle says that because it's 120, this angle will be 60. This side over here will be x root 3, or it'll be the root 3 side. So if you choose, this will be 1, this will be 2, this will be root 3. So your coordinates at this point, if you use that triangle, that special triangle, the coordinates would be negative 1 comma positive root 3. So now you can figure out the sine ratio of 120. Oh, and I made a mistake. I should put negative there because the arrow is pointing opposite the x-axis. So this is negative, this is positive, so the sine ratio is going to be root 3 over 2. I use the opposite side divided by the hypotenuse. Let's look at the next one. The cosine ratio of 60 degrees. So I'm going to draw my reference. My angle is 60. I'm going to draw my triangle so I have the right sides. So notice this side is going to be the 1 side, the root 3 side, and this side will be the 2 side. So the cosine of 60 degrees And let me just label this coordinate. The coordinate would be, the x value would be 1, and the y value would be root 3. And the cosine, as we talked about earlier, it can be adjacent over hypotenuse, or it can be the x over the radius. So going back, if I say it's equal to x over the radius, you would just use the x coordinate, and that's 1, divided by the radius, which is 2. If you want to call it adjacent over hypotenuse, that's fine as well. The answers will work out to be just fine as long as your reference angle is in the right position. Triangle's in the right position. Next one, tangent of 225 degrees. I'm going to pause, and I'm going to let you guys take a moment to try this out and draw it up yourself. Okay, I did the problem while you guys were working on it, and here's the answer. So hopefully, if you need explanation, we'll just go through it real quick. I drew my angle for 225 degrees. That was 45 degrees beyond 180. I then labeled my sides for 45, 45, 90, and my coordinate is -1, -1. And then I wrote out my trig ratio for tangent of 225. I either thought of it as opposite over adjacent, or I thought of it as the y coordinate divided by the x coordinate. Moving along, we'll look at the next problem, and I'll leave this for you to work on, and then I'll come back after you've had some. You guys can start the video after you've had a chance to try it. Okay, I'm back. So I drew the 300-degree angle in standard position. I put my reference angle in the appropriate place. I labeled my sides appropriately, and then I gave it the coordinate of +1, -root 3. And now I can either consider my old definition of cosecant or my new definition with radius over the y value, and then I rationalized. Now let's find a trig ratio with a reference angle of 0 or 90 degrees. So this is where your angle lands on a quadrant line. For example, in the first one, the angle is 90 degrees. So the coordinate of this angle would have values such that its x coordinate would be 0 and its y coordinate would be, let's say, 1, or any value you choose. And then when you go to find the trig ratio, if you have the sine ratio, let's say, of 90 degrees, and if you use the new definition where we use the y value over the radius, what you would get is the y value is the radius. So you'd have 1 over 1 for your ratio. So this is kind of difficult for kids to see because they don't view this side of the, now that's supposed to be a circle, but when you're in this position, the radius and the y value are the same. So we'll do a couple more problems and hopefully you'll catch on, and it might be a discussion for class. So let's look at the next one. Cosine of 180 degrees. So I'm going to draw my angle at 180 degrees. So this is 180 degrees, and if you look at the coordinate is going to be -1, 0, because the x value, it's all in terms of x, and there's no y value for that side. So when you look at your trig ratios, let's say cosine of 180 degrees, that would be equal to the x value over the over the radius. And because they're equal to the same value, you have -1 over a radius of 1, so the cosine value is -1 overall. Now we have all sorts of gimmicks and ways to get you guys to remember these values for at the quadrant lines. For instance, on the tangent of 270, we're going to draw an angle that goes to 270, and the coordinate here again will be it'll be 0 in the x and -1 in the y because it's pointing down, so that's -1 length. So the tangent, from what we said before, is equal to the y side over the x side. So if you look at this, we've got a problem because the tangent of 270 has us dividing by 0. We have -1 for the y, and we're dividing by 0. So in this case, we would say the tangent of 270 is undefined. Let's see if we have one more example. Well, we don't have any more examples of this, but I'm going to show a little pattern trick to see if this helps you along with this in a couple minutes. So let's just take one more thing with some patterns worth noticing. How to check the sign of your trig ratios. So when you're done doing your work on your trig ratios, there's a saying, all students take calculus. It's ASTC, and you put those letters in the coordinates, and it tells you that if your angle lands in one of those quadrants, let's say it lands here, and your angle is in the S quadrant, then all the trig ratios that are positive there are the sine trig ratios and the cosecant trig ratios. They're positive. The other trig ratios would be negative. If you happen to land in the fourth quadrant, then the cosine ratios and secant ratios are both positive, but all others are negative. So as a question to follow up with this, I'm going to be asking, what would the t quadrant represent in terms of trig ratios? Which ratios are positive? And so I hope by now you've guessed tangent and cotangent. So, and then in the first quadrant, if you ended up in the A quadrant, that would be all trig ratios are positive. Okay, class, so the last thing we want to do is we want to wrap it up with maybe a couple examples. So let's just consider that someone gave us the cosine of 210 degrees. What we should do is, again, remember the steps. We want to draw out our triangle, find out what our reference angle is, draw our sides for that reference triangle. So we remember that we have one side to be this would be -1, this would be -√3, and this side would be 2. And then we do the cosine would be -√3, the adjacent, over the hypotenuse of 2. Let's consider another example where they give us the sine of 270 degrees, and on this time, at this time, we'll notice that that brings us to a quadrant line. When we have a quadrant line, we have to remember the coordinate method of doing things, where we have the coordinate of the coordinates here will be 0, -1. And the radius is also equal to what the y coordinate is. So in this case, we're going to have the y value over the radius. So in this case, when we have the sine of 270, it's going to equal -1 over 1, which will be just -1. We'll try one more example. Let's say that we have the cosine of 315 degrees. We draw the angle and come all the way around to 315 degrees. The reference angle is 45. We draw a reference triangle, so we end up having +1 for this side, -1 for this side, √2. And we can now give our, if we want to use coordinates, the coordinate at this point would be 1, -1. And our cosine ratio is equal to the x side over the radius. So in this case, because of our triangle, the radius in this picture is equal to √2. So our will be 1 over √2. And our ratio of sides would be √2 over 2. And I just want you to notice that in this ratio, notice it was negative. It's a cosine ratio, and we'll just do a quick double check. All students take calc. It's in a tangent quadrant, so cosine would be negative because it's not in its own quadrant. For the sine ratio, notice the sine ratio was negative because down below here, this is it's either a T quadrant or a C quadrant. It's not an S quadrant, so the ratio has got to be negative. And in this one, the last example, the angle is in a C quadrant, so notice how our ratio was positive. I hope this lesson, although it's been 30 minutes, I hope this lesson has helped you understand what to do with these special angles. And we'll talk more about it tomorrow. Have a good day.